Hello, everybody, and today we're going to be talking about generics, delegates, and some lists. We'll talk about some lists. Why are we talking about that? Well, because a lot of people are confused about it. I got a few messages here, and as you can see, people want an example of certain types of lists of T, dictionaries. People are a little bit confused about that. We had some examples that we were doing together, but I think we need a little bit more understanding of it. So also you see down here, need a little bit more understanding of generics lambda. That's another one we'll be going over, dictionaries, and so on. So that's why we're doing generics today. Now, if you go to learn.microsoft.com, you'll see a whole bunch of information up there concerning interfaces, classes, namespaces, and even generics. But a lot of times when you're a beginner, you can read this. Yeah, you can read that generics introduces the concept of type parameters to .NET. Generics makes it possible to design classes and methods that defer the specification of one or more type parameters until you use the class or method in your code. Now, they give you an example, but a lot of times this still is not enough. So we're going to make this a little bit easier, hopefully, and we're going to give you an example that maybe makes more sense. So let's go to the realm of story, okay? We'll go to a little bit backstory and we'll look at it this way. So when we're talking about generics, right here in this video, I'm basically going to show you a mixture of Naruto and a mixture of Dragon Ball Z in some way. So even if you don't know the cartoon, you'll get the references. Let's take a look at Naruto for a second. When it comes to Naruto in the world of generics, Naruto is a ninja. If you haven't seen the anime, he's a ninja. He goes to ninja school. If you haven't seen the anime, go watch it. But in any case, to understand generics, all you have to know is that Naruto has a special technique, shadow clone. It's special because he uses it all the time. Other ninjas can do this too, but not to the extent of Naruto. He's mastered this thing to a large extent. So the shadow clone technique allows him to turn himself into various things. For the most part, he normally turns himself into a ninja because Naruto's a ninja. So he will clone himself into many ninjas. How is this related to generics? Well, basically, let's take generics out of the situation, okay? So let's say if he wanted to turn himself into ninjas, he would use one technique. If he wanted to turn himself into a bowl, he would use a different technique. If he wanted to turn himself into, let's say, like a frog or a woman or whatever, he's going to use a different technique because Naruto does this. He turns himself into a woman. He turns himself into trees. He turns himself into weapons sometimes. All kinds of different things he turns himself into. So with that premise, you understand there's a lot of different techniques he would need in order to do that. So let's now bring generics in there. Now you just say, instead of all those different techniques to do that, why don't we make one technique called the shadow clone? That one technique will allow him to turn into different things. So he can use the shadow clone technique to turn into all the ninjas, to turn into the bowl, into the snake, into the rock, into whatever. But it's the same technique. That's generics. So let's take a look at this inside of Visual Studio just for a second. So right here, I can go ahead and create a list. So I have this list, right? And I want to make this a list of something. So I'm going to say a list of, which we don't have this class, obviously. I'm going to call this Naruto. So I'm going to call that, I'm going to give that clone the name class. And I will say that equals a new Naruto clone class. And I'll close that off. So this is legitimate only if I had this class here. And I can go ahead and generate that in a new file or generate that class. So I have that class right here. So that way we don't get the error in a generic list. But now it takes Naruto clones. Now let's think about dictionaries. It's almost like a scroll, but it has two parts to it. has a key, which is the name written in the scroll, and then it has a value, which is when you say that name, that's the power that comes out. That's the value of it. If you want to think about it also, you can think about it like a phone book, right? So you look up someone's name and then you get their number. So let's take a look at delegates inside of Visual Studio. So if you want to think about delegates, we can think about the fusion. If you remember, if you don't remember, there was an episode of Dragon Ball Z, a couple of episodes where two fighters would do a particular move or dance, right? And they would join together. There was a fusion between Goku and Vegeta and Gotenks. There was a fusion between the two characters. And basically they would do a dance and then they would sort of fuse their powers. And so their powers were sort of, it was multiplied. And they had all kinds of different powers that they can do at the same time. So it allowed them to occupy one body and perform many different tasks. So they made this fusion. In essence, delegates represent that same thing. Delegates are when two warriors combine their techniques. So let's say Goku, who has his Kamehameha, and then Vegeta has his final flash, right? So the delegate says, let's make a move that can call any attack as long as it follows the same form. So if they both follow the same form, meaning they both do the dance and they merge, then we can go ahead and call any of those two attacks. Right here, we just have a console write line. It's just writing something to the console, right? Then we have Goku's move. Now, Goku's move is the Kamehameha. That's the function. And that function has an identity. It has a definition, meaning this function it takes in a string with a name. So this is the definition of this function, Kamehameha. And that function will run this code. Now let's look at Vegeta's move. His is the final flash. Now you're going to notice something here. In the final flash, it has the same definition as Goku's move, Kamehameha. So it has a string and has a name. So these two have the same definition. And what this one does is it writes to the console using that name, and it writes the rest of this along with it. Now here, this part right here is not the delegate. This right here are two different functions that basically push out the name. They're not even combined yet. Okay. So here's where delegates come into play. Fusion right here. We call this delegate fusion. We're going to create a variable, and that variable is going to be of a type attack. So that is using delegates. Now I'm going to highlight this attack so you can see where this attack is coming from. I'll scroll all the way up here, and you can see this is the definition of the delegate. And this delegate says it's called attack, but it must have this definition. So it has to have a string name. So whatever has that, whatever dances that way, whatever has that, can be used inside of this delegate. So when we go back down here, yes, Kamehameha has it and Final Flash has it. And we go down here. So we can literally say this fusion equals Kamehameha. Yes. And this fusion also equals, plus equals means this plus whatever I'm about to give you. Final Flash. So I'm combining these two, right, inside of this one variable, which is an attack. So because now both of them can be accepted, because both of them have the same definition, I can use them inside of this variable. And then when I put them both, when I put the name Vegito in the fusion function, which is this attack, both attacks will fire at the same time. So when I write the console.writeLine, both of these will run, meaning putting Vegito in here is like putting Vegito inside of here and running it, and putting Vegito inside of here and running it all in one shot. Whereas before, what I would have had to do is I had to run this by itself and then run this by itself and then combine them. Now, the next one we want to look at is Lambda. Lambda, in a way, is shorthand for a lot of things, right? So you want to combine a bunch of moves, but you don't want to have to keep doing those moves over and over again. So it really is shorthand. It's almost like a shortcut to do exactly the same thing. But let's look at an example here in the code. So you remember the first example I gave you where I replaced this right here. But basically, that's like adding these two brackets from here and at the bottom, right? So instead of doing that, I just do this. I can replace this with these brackets every single time, and that's Lambda. Let's look at another Lambda expression. If I were to say something like this, if I would say x, and x will be, I'm just writing it here so you can see it, but basically, this is like shorthand for saying square this number. Now, there's a longer way to write this out, obviously. But sometimes you do want things shorthand. Now, what I will say about lambdas is if it makes things unreadable, it's not important for it to be shorter. You really want things to be readable more than you want things to be shorter. So if your team is confused by this, then just use the brackets. If your team is confused by what I just wrote, just write it out. It's better to be readable than have it shorthand when it comes to object-oriented programming. So let's say if Bulma created some kind of capsule that can hold anything, right? So I'm going to go down here, my code, and let's say I was going to create some kind of class. I'm going to go outside of this. I'm going to create a class, and that's going to be called capsule. Now I'm going to give capsule, let's say, public T. And I'm sorry, I'm going to move this up one. So we'll move it from there, right inside of there. Okay, so in this same class right here, this class right here is a generic class. Now, with this class, I can basically put anything in that class or make any type that class. For example, down here in, let's say, this code up here, let me put it, I'm going to put it in, I will put it in, let's do it up here, just for the sake of demonstration. So let's say I had a variable, and that variable is called house capsule. And that variable equals a new capsule. Okay, now in that capsule, what do I want to put? I want to put a house. So let me go ahead and make the class of a house. I'm going to go down here, and I'm going to make another class. I'm going to call that house. And because I know I'm going to do another class, let's make another class called car. So now when I go back up here, I'm going to make another variable. That variable is going to be called car capsule or capsule, and I'm going to put a car in there. So I'm going to So now we're looking at the heart of generics. I can write one technique, capsule, and use it for different types. So if I go down here, I have one technique, and I can use it for various classes. It could be 100 different classes using this one technique instead of writing this over and over again for different classes. So if each one of these classes are able to do this, I can go ahead and throw them into this generic. So this is the other side of generics. The first side I showed you is when we went on and created a bunch of clones, the shadow clones. And this one right here is just basic generics. So I'm going to remove this, and let's take a final look at this code that we have here. Right here I have a capsule class that I created. Oh, I created that earlier. Let me remove this right here. So here's the capsule class I created earlier, which is generic. And I think what I'll do is I'll paste this inside of the discussion area. So if you want to copy this, you can use it. Oh, I think it's in the description of the video. Yeah, I'll do it there. Or I can put it on the Discord. So we have here the generic here. And then down here, we have our working program. We also have our delegate here, and we learned how we used that early on. So when this program starts, it starts this task. And the task simply means that, you know, this can run in the background while other things are running. So none of these can stop the application because it's running in the background while other things are running. So right now, I'm not going to go in deep into tasks. That's a different subject matter in some ways, although we're using tasks here. And so here, right here, we have this console write line. Then we have the shadow clone technique, and then the different techniques that's running here. And if I go to each one, you'll see right here is the shadow clone. It writes, it does these things. It adds to a list, and then it runs this one here. Everything in here runs. Here, what we're doing is we're giving this power level. Let me show you what this power level is. This power level is a dictionary. So when we're looking at this power level, the dictionary, it has a string and an integer. And that string and integer is the definition of this dictionary, which we have to call power levels, and we create it as a new dictionary of strings and integers, right? So when we use it, we use the name right here. We call the string part, the name part, and then we say what that name equals. Same thing here. Vegeta equals Krillin equals that. And if you notice, Goku is over 9,000. So right here we have, now we go to our write line, and we can go ahead and write Goku's power level, and we say power level, and we just say the word Goku because that was the index in a way that we gave it. So then this will print out 9,000. That's how dictionaries work. Okay, so that's that. And then we go to our fusion dance, and we talked about our delegates here, how we created this function and this function. We went up at the top and created our delegate called attack, and we created this function, this variable, which is of a type attack. So that way we can combine this one and this one to print out both at the same time. Then we make some space down here. And lambda, you remember what I said about lambda? Shorthand. It improves the quality of the code sometimes, and other times it does not. So it improves the quality of the code sometimes, and sometimes it does not. Meaning, if it's not readable to you, it's probably better for you to write it in the long way for your team and for yourself. If it makes things much easier, and it also makes it readable, you want to go ahead and keep that. And then we have our tasks, which we'll talk about some other time. I don't want to make this too long. It's already long enough. We'll talk about that sometimes. And when we get to tasks, we'll start talking about delays and timing and stuff like that. So hopefully this video was good for you. Hopefully you learned a little bit. And I can make some more videos, maybe do some animation, make it a little bit funny. But hopefully this made a lot of sense to you. And it might be better if I made one video per subject, so that way it doesn't have to be so long and it's short and simple. But I think that we basically have an understanding here. Generics, shadow clone. Dictionaries, scroll, you say the name, and then the power comes out. And then we have our delegates, where we created our fusion of different everyone does the same dance and they fuse together, and so that way they can fire at one time, or you can choose which one you want to fire using that same delegate. And lambda, we can just say that as short code, shorthand for different things. So he does all these, Naruto does all these moves, he learns all these moves, and then they condense it down into a hand signal. So all that stuff happens in one shot. And I also gave the example of the brackets, right? So in order for me to remove those brackets, I used the lambda shorthand, so I didn't have to have the brackets at all. So hopefully this video was helpful. And if you have any questions, leave them in the comment section below. And if you're on a Discord, go ahead and leave the comments there as well. And like I said, I'll go ahead and put this code here if you want it inside of the discussion on the Discord, and I'll put it inside of the description in the video. All right, I'll see you guys next time.